Today we're going to look at transformations on functions and what those look like on the graph. Before I get into it, I'm going to go over here and go over the warm-up with you. So I asked you to figure out whether this function was even or odd. To do that, we need to plug in f of negative x and see what happens. So 2 times negative x to the sixth minus 4 times negative x to the fourth plus 3 times negative x squared minus 4. So if it's even, once I run through this, distributing my negative out, I'll get the exact same thing. If it's odd, every single one of these signs will be the opposite. And if it's neither, then neither condition happens. So negative x to the sixth, that's going to be positive x to the sixth. So this is 2x to the sixth now. Negative x to the fourth, well, it's to an even power, so that'll be positive x to the fourth. That is multiplied by negative 4 times positive x to the fourth. So negative 4x to the fourth. And negative x squared is going to be positive. So positive 3 times positive x squared. And then negative 9 kind of stays along there. So let's compare it. If it's the same thing, which it kind of looks like it might be, then this is an even function. So it looks like all signs stayed the same. Oops, that was supposed to be a 4, wasn't it? But it looks like all the signs stayed the same, so this is definitely an even function. Now getting into the actual lesson, these are the 5 types of graphs that you need to make sure that you have a pretty good idea of what they look like and kind of their basic properties. Usually I give a summer assignment, and part of it is knowing, or being pretty familiar with all of these types of graphs, what they look like, recognizing their shape, knowing key things like vertices, places they may spring into existence or stop existing, important things like that, asymptotes. So make sure you're pretty familiar with these 5 types of functions. If not, and you have any issues, I'll clear them up later. Just let me know, and just give me a message or something. I'll clear them up. So here's the main types of shifts that can happen to a graph. And I'm going to switch over to Desmos in just a second and play around with it so you can see this actually happening live. So if I have a function and I add a number to the end of the function, think about this. F of x is y. So I'm going to add something to the y value that really just raises it or lowers it, depending on whether I add a positive or negative number here. So it's a vertical shift. Okay. Things inside the parentheses get a little tricky. Some of the homework problems, I'm sure we'll have some questions to talk about. But basically, they move things left and right. And kind of opposite what you might expect by the sign, but that creates a horizontal shift. Okay, putting a negative in front of the function itself. All right, so we kind of messed around with that with an odd function. So you've seen that a little bit already. F of x, again, is a y value. So negative f of x means the opposite y value. So that's a reflection. That flips your y values to the opposite of what they were. Okay. Here's something in parentheses again. So this is going to be a horizontal change. So f times something times x. This is kind of weird. We'll probably have some homework questions about that. But it is a horizontal stretch or shrink depending on what number you put in there. Generally, how that number relates to 1. Is it bigger than 1 or smaller than 1? That's kind of the key critical point. And then finally, n times f of x. So a number times my y value, that makes my y value bigger probably, so that's a stretch. Or it could be a shrink if I put a really small n value like 1/10. That makes my y value 1/10 the size it was, so that would shrink it down. So that's a vertical stretch or shrink that way. So let me switch to Desmos, and let's take a look at a few of these functions. Let me just run through what I've got here for you right away. First up, here's standard form for a parabola. All right, should have spent a lot of time with that in Algebra 2. And there's what it looks like on the graph. Next one is standard form for a square root function. And we'll go through what all these letters mean in a second. So there's your basic square root function. That's an example of one that sort of springs into existence. There's a definite starting point, and from that point onward, it exists, but it didn't exist up till then. Okay. Here's a typical absolute value function. That's the V shape. And then finally, a rational function. Right? These do have asymptotes. And We'll get into asymptotes more and more throughout the year as we go on, but that's kind of their key thing to make sure you graph. So let's start with the parabola and look at how these changes affect things. Now, this is posted on the website. Let me pull that up for you real quick. If you go to my website and look at the lesson, chapter 1 notes, at the top here, if you click on that link, it will pull this up. I believe everything's kind of highlighted all at once. It might look kind of crazy like that. Just click on the little dots here, and that's how you turn a function on or off as far as whether it shows up on your graph. So let me run through the parabola first and kind of reiterate some of these points that I was just talking about on this page. So standard form of parabola, we have something, we could have a number out front of x. We could have some number inside here with x. We could have a number after everything's all said and done. And something else we could do is have a number right here in front of x. For the sake of this example, I think it kind of makes a little too much going on, so I'm going to leave that out for now. So let's start with A. Now, again, if you'd ever play with Desmos, what's really good about it is you can create the formulas the way they in their standard form, and then you can create these sliders where you just change the variable and see what happens. Or you can hit play and just kind of roll it out and make it animated. It's fun to make animations. One day I had a challenge to make a bunch of birds flying around off of this. So I'll show you that to you one day. So anyway, the number out front, that's going to be a vertical change because it's out in front of the function. And this is just stretching it or shrinking it. Again, one's kind of that critical value. When you get if you get smaller than 1, it starts to really shrink it down. If we got to 0, it would be a horizontal line because it'd be nothing times all this other stuff. Okay? So that's what the A value does. Okay, H is inside with X inside the parentheses. So that's going to be a horizontal change. It's going to slide it left and right. Okay. Now, I put a negative in here already. So when I say negative, when I have 1 for H, for instance, that's X minus positive 1. So when you see X minus 1, that moved it to the right 1. It kind of goes opposite what the sign looks like. Unless you think of it being X minus whatever the number. I'll let y'all sort that out when you practice with it. But it's a horizontal shift left and right. Okay. So I'm going to put that back to 0. And finally, K at the end, that's a vertical change because when it's all said and done here, you're just adding something to the Y value. So suppose you put in something for X, get a Y value out. Now we're just going to add a little bit to that, raise or lower the graph. So when you change K, it moves it up or down. Okay. All right, and we'll reset that back to 0. And let me just run through some of these others briefly with you. Square root function, same thing. A is going to stretch it or shrink it. Something I didn't point out earlier, I could probably put the parabola on here with this. If A goes negative, all your Y values become the opposite of what they were, so that gets reflected. It's flipped upside down. Okay. Same thing with H and K are going to move it left and right. K is going to move up and down. Absolute value, pretty similar. And finally, rational function. I just want to run through this a little bit. Pretty much same deal. The A value is, A value is not on there, so don't have to worry about that. H, again, is going to move it left to right. So the number that's with the X on the denominator in this case, not really in parentheses, although denominators are kind of understood to be in parentheses, so you could think of it that way. And K at the end here is going to move it up or down. So that's the basics. I'm sure there'll be some homework questions and some common things I'm going to post on here that usually come up so you can kind of see how to work them out. But that's the basics to get you started. Feel free to, again, go to the website, click on that link to Desmos. It brings you right here to this page, and you can play around with these on your own. I usually give time in class to just kind of play, and that usually is pretty helpful for students just to get in here and mess around and just get a feel for what's going on. So definitely just, you don't have to spend long. Just try it and mess around with it. Sometimes you might have too much fun and start making your own animations, and that's okay too, but just don't forget the assignment.